going to start from setting up our work environment. If you already have Linux installed, then you can skip to the good part, the tips and tricks section. The first software we need to install is VirtualBox. It's a management tool for local virtual machines. So we go to a search engine and type in there VirtualBox download. And the very first link is the one we need, as it leads us to the official VirtualBox website, virtualbox.org. We click on that link to move right to the download page of the website. Here we can see all the possible download options for different operating systems. Ours is Windows, so we click on the first link. Then starts the downloading process. After it finishes, we launch the executable file that has just been downloaded. We easily go through the setup steps in a way like next, next, finish. And the VirtualBox window will show up in the end. We're going to leave it for a while until we download Linux Ubuntu, which we are about to install. So we switch to our browser and make new search request, which is Ubuntu download. The first link, which leads us to ubuntu.com website, is the one we need. So we move to official Ubuntu website. Here we scroll until big green download button. But before we press it, let's discuss the recommended system requirements listed on this page. So, it's 2 GHz dual-core processor, or better, 4 gigs of RAM, 25 GB of disk space. But in fact, if you're going to use Linux Ubuntu for study cases only, you might reduce these requirements by 50%. A little life hack from a teacher. Anyway, we press the download button to get an ISO image of the latest Ubuntu. Keep in mind that this file is quite heavy, several gigabytes, so it can take some time to download it. When it's done, we switch to VirtualBox window to create our brand new virtual machine. So here we go to the machine menu and pick the new option. Then we fill in a pop-up window fields, virtual machine name and folder where its files will be located. Please note that the chosen hard disk has to have at least 20 GB of free space. As we mentioned the Ubuntu word in the name field, the VirtualBox interface automatically filled in for us the type and version drop-down lists with appropriate values. We press next to go to the further step of virtual machine creation. Here we choose the amount of RAM and the number of CPUs. As we saw on the web page, the recommended amount of memory is 4 GB. But for our study cases, 2 gigs is also enough. So let's pick 2 processors for better performance during the installation process at least. And let it better be 4 GB of memory. Click next. In the next step, we define the amount of disk space that our machine will use. Make sure you have that amount of gigabytes on your disk drive. We will leave the recommended amount as the interface offers us. In the next step, we can check all the options we have set for the machine that we are about to create. If everything is okay, we click Finish. And our virtual machine itself has been created. But it's empty, so there is no any Linux yet. And to set it up, we have to install Linux from the downloaded ISO image. So we do the right mouse click to enter virtual machine settings. In the settings pop-up window, we pick the storage in the left menu. Within the storage devices list, we need the one with compact disk logo and the title empty. And now by pressing the disk sign on the right, we choose an ISO image of Linux Ubuntu that we downloaded before. Now most likely our virtual machine will get started automatically. If it doesn't happen, we can double click its icon on the left. Now we will go through the steps of Ubuntu installation process. It's pretty similar to Windows installation, but if you haven't done anything the same before, don't be afraid, there's no black magic. Every step is pretty reasonable. Now we pick the first option, try and install Ubuntu, in the black window menu, and wait a little for the installation process to start. In the welcome step we choose install Ubuntu. In the next keyboard layout step, we can choose the preferred language and keyboard layout. We're leaving here everything as it is, i.e. English by default. Click Continue. Here I would recommend picking Minimal Installation, so that it doesn't include a lot of software we don't need for our study case. But it's up to you. Click Continue and Install Now. Confirm by pressing Continue again. The next step offers us to choose the time zone, but usually the one it defines itself is suitable. Now we're going to fill in a username, computer name, and a password to login. I would also tick the checkbox Login automatically, so that it doesn't ask us after each reboot. Click Continue and go get some coffee, as this process will definitely take some time. We will fast forward it to save your time. It offers us to restart, we agree. Okay, great. Now it's our first launch. Probably Ubuntu will offer you some first setup. If you want to, you can go through it or click Quit. Our goal is to launch the terminal. So we press All Programs button down in the bottom corner and type Terminal in the text box. Then we pick the icon it offers us and bingo, here it is, our terminal. This is the window we are going to spend all our course in. On the taskbar we can remove the icons we don't need, and it could be convenient to add to favorites our terminal window. By default, Ubuntu checks for updates periodically and offers us to install them as well. If it shows the window about it, we can press Install Now button. Update process though can take some time too. Most likely we will have to reboot again. And one more final step before starting using our brand new Linux Ubuntu. It is recommended to install so-called guest additions. It is a piece of software intended to ease our life in virtual machine. For example, it helps seamless mouse movements between host OS and virtual machine. So, to install them, we go to Devices menu. Here we pick the last option, Insert Guest Addition CD Image. If it doesn't automatically open a window to initiate installation, then we manually press the CD icon on the taskbar, and in the open folder find autorun.sh file, right-click, and pick Run as Program menu option. It might ask us to enter our user password. We do it and everything else will be done automatically for us. Now we finally can open the terminal window again and start enjoying the process of learning Linux terminal. So let's dive in. In this section, we installed VirtualBox, the manager of local virtual machines. We installed the Linux Ubuntu operating system and launched Linux Terminal, our work environment for this course. So now we're gonna learn some terminal tips and tricks to improve our productivity and to become way more efficient and probably even compared to our older colleagues. For example, if we see that our terminal is overloaded with different info we would like to get rid of, we can do it by clear command. We type clear and press enter. So we can see our terminal is clean now. And there is a hotkey for this command as well. We're going to create some mess here again to demonstrate it. Then we press Ctrl L and we can see the same result as after clear command. But in fact it doesn't really clean anything, because we can scroll the result back after this command and all the previous commands are back on our screen, huh? The next useful hotkey is Ctrl U, which helps us clear everything to the left from cursor. Let's type some long line and then press Ctrl U. Once again, look, if we place the cursor somewhere in the midst of the line and then press Ctrl U, we only get rid of the left part of the text. To clear everything to the right from the cursor, we press Ctrl key. So Ctrl U clears text to the left, Ctrl key clears text to the right. One more useful command for cases like these is reset. It can help us fix the screen output when it gets a little bit broken. For example, when we outputted some specific non-displayable file symbols. So reset, enter, and our terminal look is as fresh as new. Now we will take a look at different options to find help for our commands. The first way is typing what is before the required command, like what is clear. This always shows us one-line description for the command. Now we can read that clear command is used to clear the terminal screen. Or what is history, to show one-line help for history command. Or what is reset. The other option is help command, like help history. This way we see more detailed description of the command. Or help cd, to see some info about cd command. One more way to show command description is -- help option typed after command, like history -- help. As well, there is man command, which is, by the way, reduction for the word manual. So if we type man clear, for example, then we will see the most detailed description for the clear command. We're gonna scroll down here because there is a lot of text. To exit this help page, we can press the Q button on the keyboard, which is hinted at the screen bottom, by the way. Also, I would like to draw your attention to the letter case importance in Linux. So we type commands only in lowercase. You can see that man command in uppercase won't work. We can see the error text command not found, while man in lowercase works just fine. Similar to the man command, there is info command. You can use this one searching for help as well. If we forget a certain name of the command we want to use, then we can start typing its name, the part that we remember at least, and then press tab key twice. Like this. We type hi for history and then tab. And now we can see options that our terminal offers us for the commands starting from HI symbols. And the last option we're going to take a look at is apropos command, which can be useful for the case when we forgot the exact name for some command. Like this, apropos his. Enter, and then we see all the available similar looking commands. We have already used the history command, so let's talk about it in detail. This command allows us to look back at the list of the commands we recently used. As one of the history command arguments, we can use a number, which means limitation of the commands we want to see. Like history 5 or history 10, so that we see only the required number of recent commands. As you might have noticed, every line in history command output starts with a number. This number can be used to address certain command from this list. We can do it using exclamation mark. For example, exclamation mark 37 to run the 37th command again, which is man clear command, to bring out to the screen manual for the clear command. Remember the Q key to get back to the terminal command line. One more case to use history is the double exclamation mark command. Using it, we can run the previous command. Also, we can use exclamation mark like this. Exclamation mark -6 to run the 6th command from the tail of the list. In our case, this is gonna be man clear. And here it is. If we want to search within the history of used commands, we can press Ctrl R and start typing needed command. The terminal will then show us available options. We press Tab to use the chosen one and the command gets run. Let's take a look at a few more tricks with history. We can clean commands history by typing history-c. Then we will output actual history and find nothing that was there before. Now we're gonna run some random commands to create new history. Check it out. Here it is, brand new. there is a possibility to hide some command from history. Ordinarily, every executed command goes to history, like we run ls and then can find it in history. But if before execution of some command we put a space in front of it, then it will not go to history. See that cd / command hasn't been written down in history. This is how this trick works. So in this section we have covered the next topics: some useful terminal hotkeys, getting help for commands, and working with commands history. The current directory path can be shown using pwd command, which stands for print working directory. On the screen you can see that our current location is /home/itguy, which means that there is the home directory in the root of the file system, and within it there is an itguy directory. To change our location in the Linux file system, we can use the cd command. And surprise, surprise, cd stands for change directory. We can use it like this: cd/home, and this will bring us to the root home directory. pwd output proves that. We can get back to itguy directory by typing cd itguy, and we're there. And there's an option to move to the parent directory, I mean parent to our current location. So if we type cd ... then we will end up in /home directory, because /home is the parent to /home/itguy. So in any Linux path, the slash is the symbol that divides folders names. We can type cd ... again, and this will mean that we will go to the very root of the file system, which is denoted by the slash symbol itself. If we try moving to the parent directory from the root folder, which is slash, this will not bring us anywhere else, because there is no parent for the slash, and this action is not causing any error as well. There is a tilde sign in the Linux file system. It means the home directory for the current user. So if we type cd tilde, meaning that I want to go to my home directory, I will end up in /home/itguy, because I'm working now from a user named itguy, and that folder is his home directory. Also, we can change our location like this: //war, for example, which is going to move us 2 times to the parent directory and then to the var folder. And let's see where we are. /var. cd - command can move us back to the previous location. So we're now in our home folder. If we type cd - again, then we will go to the /var folder back. Let's move to our user's home directory by typing its full path: /home/itguy. In general, there are 2 ways to write the target path for the cd command. Starting from /, this is called an absolute path, and starting from whatever else, it is a relative path. The difference between these 2 types of path is that using an absolute path, we don't care about our current location at all, while typing a relative path, it's being formed based on the current location. Now let's discuss our folder's content. There is ls command, which shows us files and subfolders within the current or specified location. So typing just ls will output to us the current folder content. We're now in our user's home directory, and those outputted blue titles are the names of subfolders. Look what's interesting: if we add -a key to the ls command, then we can see many more lines in the output. The reason is that hidden files and folders have been added to the output by that -a key. Also, we can notice that those added files and folders start from dot. The idea is that in Linux, to make a file hidden, you just start its name from dot. So neat, huh? The ls command also has -l key, which changes the output to the look like this. See, now we have a table view of the folder content, and file names here are only in the last column. In addition, we can use these keys in the ls command together, like ls-la or ls-al or ls-a-l or ls-l-a. All these commands will output for us the same result, which is both the table view and includes hidden files and folders. So far, we outputted the content of the current directory only, but we can specify the folder path that we want to see, like ls/var, to see what is there within the /var folder. The option to use specific keys to change our output is still there as well. So we can add -l key to have table view or -a key for hidden files. In general, the ls command can have a folder specified for output and some keys to change the output look. By the way, our Linux Ubuntu has one alias for ls-la command. It is ll command. We can see that output of these two commands is pretty much the same. So ll command is an alias for ls used with -a-l keys. So in this section we've covered the topic of basic navigation commands, such as pwd command, cd command, ls and its alias ll command. For creating folders in Linux, we use mkdir command, which is usually pronounced as makedir. So we type makedir, then folder name, enter, and here's a new folder which we named Linux course. ll or ls commands can be used to check the result. Let's move into our new folder by the already known cd command. Of course, our folder is empty as we haven't created anything there yet. By the way, a little comment on ll command. You might have noticed that the output of the ll or ls-la commands always starts from two lines. The first ends with a dot, the second ends with two dots. So the first line ending with a dot contains the info about the current folder where we are located now. And the second line, which ends with two dots, is the parent folder for our current one. There is also the option to create multiple folders by one command. So we can type something like makedir folder1 space folder2 space folder3 and see all these three folders being created at once. One more specific thing about the Linux file system. Look, we're going to create a new folder named folder1, which name starts from the upper F symbol. Although we already have a folder with the same name, just with the lower first letter case. So the idea is that for Linux, these two file or folder names are different, which is not the same in Windows. Because in Windows, we couldn't have created these folder1 and folder1, where names differ only with the letter case. Another way to use makedir command is this. We type makedir2/3/4, meaning that we are about to create nested folders at once. It didn't work this time because this trick needs the -p key. When we add it to the end of the command, then something gets created. Let's check it out. There is the 2 folder here that has just been created. If we go into it, then we will find one more folder named 3. Let's go into it and surprise, surprise, there's folder named 4. So we have created the hierarchy of folders using the / symbol between folder names in one command. It is suitable here to mention one more useful command, which is called tree. If we type tree and see the answer like command not found, this means that we can install it by the command written 2 lines below. I mean sudo apt install tree. So we just copy and paste this command or type it by hand and it'll install the tree for us. A little program that outputs folder structure in a convenient way. But before we use it, let's move several levels up in the file structure. Guess where we will end up if we type now cd ... huh? So it'll move us 3 levels up, and we're now in the Linux course directory. The pwd command proves that. Getting back to the tree command, it shows us the folder structure. Now we see all the folders we have created. Directory 2 containing directory number 3 containing directory 4, and other flat folders, located on the same level. Let's discuss one more case you might encounter while creating a folder. So we're up to create some new folder. Press enter and get this permission denied error. If that happens, first make sure you're creating the folder in the right location. Supposedly we're sure of what we do. Then we need to claim the admin rights for our command. We do it by the sudo prefix for the previous command. So we add sudo run command and it works just fine. But when we check the result, there's no folder that we have created. Where is it? It is located not in the current location, but in the root of the file system, as our path for creation of the folder started with the / symbol. So we will find our folder in the place where we put it, in the root of the file system. In Linux, there's definitely more than one way to create a file. And now we're going to discuss this topic. The first way to create file is using touch command. So we type touch, then the name of the file, and here it is. The next our option is echo command, with the greater than sign and followed by file name. So the new file has been created as well. Also, we might omit the echo command. Just greater than sign with the new file name creates it as well. Probably you have noticed that the last new file 3 has no extension. We did it intentionally. I wanted to draw your attention to the idea that in Linux file extension doesn't have that huge importance as it does in Windows, for example. So here can exist a lot of files without extension at all. They can be images, scripts, other executional files, etc. And it's okay, because Linux doesn't care about file extension if only for users' convenience. And the last way to create file that we're going to discuss now is the cat command. It looks this way. We type cat, greater than sign, and file name. After we press enter, the terminal is waiting for input from us. Everything we type now goes to the file content, and it'll continue until we press Ctrl D. Then input finishes, we get our command line back and we check the result, so a new file is here, and within it there's a text we entered just now. I wanted to pay a bit more attention to the touch command we used in this section. So this command allowed us to create a new file. But if we use this command followed by the existing name of the file, what will happen then? In this case, the date of the file is gonna get updated. So we input again touch and new file 1.txt, and we know that this file already exists. Now we can see that the date of the file has been updated. Just the date, and nothing else has happened to that file. So this is how touch command works with existing files. So in this section we discussed commands used for files and folders creation, such as makedir command, touch, echo, and cat commands. We copy files in Linux by using cp command. Let's take a look at files we currently have in our directory. We're going to copy some of them. Let it be new file 1.txt. So we type cp space name of the file space name of the new file that we're about to create, enter, and ll to check the result. And our new file 1 copy.txt is here, having the same content as the file it's been created from. We remember the tree command that shows us nested files and folders in a structured way. It's just convenient to use it to demonstrate copying files into the other directory. So let's copy all the files having names like new asterisk, where the asterisk is the alias symbol for any string. And we will copy them into the to directory. Checking the result with the tree command, and we can see all the copied files within the directory named to. We also might take a look at the to directory content and make sure all the files are there. Of course, we have a possibility to copy entire folders with all their content. So if we try doing it the same way we did it with the files, we will get the message telling us that for copying of the folders we need the -r key. So let's add it right in the end of the previous command. And it worked just fine now. The directory named to got copied into the directory named folder2. We see it in the output of the tree command. For moving files, we use mv command. As an example, let's move all the files with txt extension into the directory named folder1. Then check it with the tree command or ls command. So all those files are now located in the mentioned directory, but not in the current one, because we have moved them. We easily move a folder right the same way. So mv space the moving folder name space the destination folder name, check the result using any suitable command, and it's done. In Linux, there is no particular command for renaming files, because this operation is a form of moving. So we have to use the mv command for it. It works like this. mv, the current file name, the new file name, enter. And here it is, our new file got the new name. So if for copying files we use cp command, for moving and renaming mv command, then for removing we use rm command. To delete a file we simply type rm, target file name, and that's it. Check it out, no file. But when we tried doing the same for the folder, we got error message cannot remove a directory. It's because the -r key is required to delete a folder. If we add this key, the folder will be gone. Now we are going to type this command, rm f *-r, which means that we want to delete all the folders whose names start with F symbol. And I've got a quick test question for you. Do you understand why this folder1 is still here, not deleted, I mean? If you do, that means you get the Linux right. The answer is that the left directory name starts with uppercase F symbol, while we claimed to delete folders with names starting from lower f. Okay, now we will delete everything from the current folder. rm *-r. Check it out, nothing is here anymore. Let's take a look at rm help, the short manual for the command. There are a few keys that I would like to draw your attention to. I mean the R key and the F key. R means recursive deletion of directory and all its content. F means forced deletion, like no questions asked. So let's discuss rm command in this look. rm -r f and /. First, guess what this short line is gonna do. rm is for removing. -r key stands for recursive, nested files and folders. -f key means forcing, and / is the directory where we're going to start from our deletion. So this command would try to delete everything possible. I put the hash symbol in front of it so that it doesn't run but stays in history. By that example, I wanted to emphasize the idea that in Linux there are many ways to shoot yourself in the foot, so be careful. By the way, there is no trash can for the files deleted from the console. In this section, we discussed basic file operations, such as copying, moving, renaming, and removing. We will take a look at different text file viewers in Linux. But firstly, we will remove all the files from our Linux course directory because we don't need them anymore. So the command that we already know, rm *-r, will do it for us. And the folder is empty. There is one more trick I want to do now. I'm going to run one magic command to download some long text file. It's not the command we're learning in this section, it's just a piece of software to help us download the file from the web. So we type wget space and URL for the required file. Downloading process might take some time, but when it finishes, we can see a new file in our folder. Its name is 1112.txt. We'd better rename it. And you have already known the command that will do it for us. It's mv. So mv, current name and the new name. Voila! The new name is Romeo poem.txt. Actually, it's the full text of Romeo and Juliet, poem by Shakespeare in this file. I took it just as an example of some long text file to demonstrate file viewer's functionality. And the first command we're going to learn in this video is more. By typing what is more, we can see one-line info on this command. Or more --help will show us some useful options. And of course, you remember the way to call the most descriptive help info on command. It's man more in our case. The Q key to exit to the console. So the simplest way to use our command is typing more and the name of the file we want to view. After pressing enter, we will see the first page of our file. Using the space button, we can bring on the next page to the screen. Using the Q button, we exit from the viewer to the command line. Let's discuss a few nice options we can use with more command. If we add dash and some number before the file name, then we will see only the certain amount of lines outputted for us. And it's 10 lines in our case. When we press space, then we will get 10 more lines of the file content. This is how this dash option works. The other option is plus sign and then some number, like plus 145, which will output the file content starting from the 145th line. So now we know that the prologue starts from this line. We can continue scrolling by pressing the space button as well. Q to exit. Of course, we can combine these options and use them together, like plus 145 minus 5, which will bring us to the 145th line of the file and show us only 5 lines from there. And the space button will show us 5 lines more per every press. Q to exit. In the short help for more command, there was an option starting from plus and slash, which allows us to search some text within the file. Let's check it out. We're going to add -5 option as well to output just 5 lines, no more. Then plus slash and string we'd like to search for. Let it be Romeo. Enter, and who would guess that there is no Romeo word in the most known Shakespeare book? Huh? And if you got the reason why we hadn't found it, then you are starting to understand Linux. So the problem was that we typed Romeo starting from the lower R, whilst Linux is strictly case sensitive. And we're going to prove that by fixing the R letter to uppercase in the search string. Check the new result. Now it's been found. Let's take a look at one more useful option for the more command. It is -s option. Now we will observe how it works. Look, in the mere output of more command, with no specific params, we can see that there are a lot of empty lines following together. And if we use -s option in the more command, then those doubled, tripled empty lines just have collapsed to one empty line. So this is the way we can use our screen more efficiently. The next file viewer we will discuss is less command. Its use is as simple as the previous one. So we can type less and the name of the file, the same way. And here we have the ability to scroll the text up and down with the arrows or with the page up, page down buttons. Exit from the viewer is also the same, the Q button. Let's discuss some interesting options of this command. Like for search, we use -p option. And then the text that is being searched should be placed within the quotes, like this. -p, quote, Romeo, quote, enter. The answer that nothing has been found means that we should either start our Romeo name from the capital R, or we can tell the less command that we don't want case-sensitive search. So if we fix the Romeo word, then we will see it emphasized in the file text as being found. When we want case-insensitive search, we do it by using -i option, and the I letter here should be uppercase, like this. And here we see that it found Romeo with only the first letter capitalized and the whole word written in uppercase letters as well, which itself is case-insensitive search. When scrolling the text down, we will see all the other search results emphasized for us. One more nice option of the less command is -n, capital N. This one gives us line numbers on the left. Could be handy for some cases. By the way, we can write these options separately, like this, -n, -i, -p, and it'll work absolutely the same way. So this is the less command, the text file viewer, that has more functionality than the previous more command. If we want just a brief look at some file, there is such an opportunity. It's head command, which allows us to output only a certain number of rows from the file. Default number is 10. So head and the name of the file will show us just 10 lines from the text file. And of course we can manage desired lines count using the -n option. For example, head -n1 Romeo poem.txt will output for us only the one line from the beginning of the poem. We can eliminate the n letter, leaving just dash and the number of lines with no change in the result, like this. Let's say we want 3 first lines or just 4 lines. There is -c option, which allows us to set the number of bytes we want to output, like -c 47 will show us the first 47 bytes or symbols of the file. And the last text file viewer we're about to discuss is the tail command. As you might have noticed, programmers like references, like less command is the reference to more command, as well as tail command is the reference to head command. It also helps us to remember all these commands. So, usage is simple and the same as the previous one. Tail, file name, enter. This will show us the last 10 lines of the file. And the short help for this command displays us info about how we can customize our result using different options. For example, if we add -3 option, this will obviously output for us only the last 3 lines of the file. -c option allows us to set the number of bytes that we want to see. The same as for the previous command, just for the end of the file. So in this section we were talking about text file viewers, such as more and less, head and tail. The first editor we're going to look at is Nano. The very short description of Nano says that its name is the reference to Pico, the other text editor, the previous. It's again about programmers love to references. Anyway, if we type Nano and press enter, we launch this editor. Let's discuss its interface. The upper white line shows us info about the editor itself and its version in the left corner. In the midst of this line, there could be the name of the file in case the text is saved. The main part of the screen takes the editor itself, where we input our text. The white line below is the info string. Here can be shown the caret position, the size of the file, etc. The last two lines are devoted to main hotkeys for work in the editor. For example, caret X means exit from the editor to the command line. By the way, the caret symbol means control button here. So pressing Ctrl X means we want to exit, or Ctrl O is for saving text to the file. To undo some action, we have to press Alt U, because the M symbol in this help line means Alt button on the keyboard. Let's say we have inputted some text and want to exit. Then we press Ctrl O to save our text first. The editor will offer us to input the file name. Let it be like new file.txt. Enter, and our new file has been created. Then we press Ctrl X to exit from Nano to console, where we will see our new file. We can check its content, it's all good. We can open the existing file in Nano by typing Nano and file name. Then we continue editing, make some changes, press Ctrl O to save and Ctrl X to exit. So new changes are here. There is one more interesting feature that Nano offers us by using -B option. Please note that the B letter is capital. Look at how it works. So we open a file with this option, edit it in some way. Let's just delete several lines of the text here by pressing Ctrl K, then save the file. And what we see in our folder, look, there are two files having our name, and one of them has a tilde sign in the end. Let's have a look at these files' content. So the first 10 lines of the original file says that it is our file as we saved it. And the other file with the tilde looks like we never edited it, which means that the last file with the tilde is the backup file created after we started editing the original file. So -B option in Nano Editor creates a backup copy of the original file. Isn't it neat, huh? Also, we can open a file using some numbers, like this, plus 3500, 20, and the file name. What this will do for us is it'll open the file and place the cursor on 3500 line and the 20th symbol. It can be useful when we finish editing a file and then the next day we want to continue it right from the line we left it before. The hotkey that shows us the info line in the bottom is Ctrl C. Here we can check the line we are at and the number of the column as well. The important part here is that we cannot put spaces here when using this option with plus sign and numbers. This way it won't work. See the error message in the bottom of the screen, double Ctrl X to exit. Let's take a look at the editing capabilities of Nano. For example, it can work with the clipboard quite conveniently. Let's say we want to exchange the first two lines of the text, for the author to be in the first line and for the title to be in the next. So we put the cursor in the first line and then press Ctrl K to cut the text from the line. Then we move the cursor to the next line after the author and press Ctrl U to insert text from the clipboard. Now let's play with text copying. So first we have to highlight the required text. We put the cursor to the needed position, then press Ctrl 6 to start highlighting. Then we move the cursor to the end of the block we are about to copy and press Alt 6 to copy. Move the cursor to the new position where we want to insert our text and press Ctrl U. And here it is, our duplicated text. Nano Editor can do search and even search with replace. After pressing Ctrl W, it offers us to input a search string. Let it be Juliet. Then we press Enter and it shows us the first occurrence. To go to the next occurrence, we ought to press Alt W. And we can go further and further through search results by using this keystroke. We'll go back to the beginning of the file and observe Search with Replace feature. So to call it, we press Ctrl/. And down in the info panel, Nano offers us to enter a search string. Let's input Romeo and Juliet. After pressing Enter, it will offer us to input the replacing string. Let it be boy and girl. Enter, and it shows us the first occurrence to replace. Look at what options Nano offers us now. They're shown in the bottom left corner. The Y does replacement for the current highlighted text. The N key means no. A key stands for replacement for all occurrences. And Ctrl+C is to cancel the whole operation. So we press Y, Nano replaces one string and it highlights the next search string to be replaced. We press Y again, and the next occurrence, let's press A to replace all other Romeo and Juliet strings in the file at once. We can now see the new strings, boy and girl, everywhere within the text instead of the original name of the poem. Okay, next feature. As long as our file is quite huge, we might need some functionality for cursor navigation. And we have it. So after pressing Ctrl, Shift and minus, the editor will offer us to enter the line number we would like to go to. Let it be 300, for example. Enter, and we see our cursor on the line we wanted. To make sure, we can press Ctrl+C to show the line info string down in the bottom. And of course, the line number is 300 there. And the last feature we will discuss about Nano now is the undo capability. To call it, we simply press Alt-U as many times as we need it. So finally, we got back to the file content that we had when we just opened the file. In the end, I will just exit the Nano editor, and I won't tell you the keyboard shortcut to do this, as I hope you have remembered it, or at least you know where the hint is shown. The next editor we are going to discuss is Vim. What is so special about it is that it is the default Linux text editor, which means that it is installed there right out of the box in most Linux distributions. So it's the editor you will most likely work in Linux. One more specific thing about it is that it looks and works not really intuitively, not obviously compared to all contemporary text editors we're used to. But the fact that it is the default Linux editor makes it very important. So that is why every person learning Linux should know at least its basic usage. One line help says that Vim is VI improved editor. So VI editor is its predecessor, although Vim substituted VI almost in every distribution. I mean, even if we input VI in the command line, most likely it'll run the Vim editor, not VI. So the simplest usage is this. We type VI and the file name we want to open. And the first thing we will learn about Vim editor is exiting from it, because it's a really tricky task if you don't know it. There's even a joke that some programmers reboot the server to exit from Vim. I wouldn't also call this editor a user-friendly one. But anyway, to exit Vim, we type colon and Q, where Q stands for quit, as you might have already guessed. Okay, great. First task has been learned. But we open text files not just for exiting from them. Sometimes we want to edit them. So we open the file again, and our attempts to write some text lead to nothing in the good scenario. So what's wrong? And here we have to learn the Vim modes. The idea is that the editor has several modes of work. Let's talk them over using this schema. On opening Vim, we enter normal mode. It's like some lobby, a starting point where we decide what we want to do. So we press I button, which stands for insert, and enter by it the insert mode. In this mode, we can edit text. To get back to normal mode, we press escape. If we want to use some commands, then we have to enter command mode by pressing colon. Now we can save changes to the file or quit from the editor or do some other command. To get back to normal mode, we press escape again. If we need a visual mode, we get there from normal mode by pressing V, which stands for visual. So this is how we switch between Vim modes, depending on what we are about to do. Okay, now when we know about Vim modes, let's check them out. By pressing I button, we enter insert mode. It's text editing itself. Then type some text, blah blah blah. To finish editing, we have to exit insert mode to the normal mode by pressing escape. And now we decide what to do next with our changes. So now we're going to save the changes we have made to the file. To do it, being in normal mode, we type :W, where W stands for write or save. Enter, and now we see the corresponding message that our file has been saved. By the way, we could have done it in some other way, like this. While we're in normal mode, we might type :WQ to write changes and quit from the editor. Enter, and we're back to the console. Let's say after some occasional editing, we want to discard our changes made to the file in Vim Editor. By the way, it's an important feature to remember first. I mean, exit the editor without saving changes. To do so, we press colon to enter command mode and then type Q and exclamation mark, where Q stands for quit and exclamation mark means like no questions asked. So this command will exit the Vim and make no changes to the file. If we open this file again, we can make sure that there are no changes. There are specific, interesting though, commands in Vim Editor. Let's discuss some of them. We can press DD to delete the line where the cursor is. And even more, if we type 5DD, this will delete 5 lines in a row. 2DW is to delete 2 words from the current position. P is for insertion from clipboard. U is undo, though 3U is undoing the last 3 operations. Let's move the cursor to some other position before talking over other commands. So, we can even move our cursor in a Vim specific way. For example, 2W relocates the cursor 2 words to the right. 10H moves it 10 symbols to the left. 3J moves it 3 lines below. 5K moves it 5 lines above. Of course, like every other respectable editor, Vim supports search. We use it in normal mode by pressing the slash symbol. And then we type the string we want to search. Let it be Romeo. Press enter and our cursor is blinking at the first occurrence. To move to the next search result, we have to press N symbol and then N again to go further through search results. Moreover, Vim supports plugins. This means that it is possible to enable syntax highlighting for some programming languages. You can add Git support. It is system of so-called control version. Some people make kind of fully functional, relatively, IDE, which is an integrated development environment. I'm personally not one of those old school guys. I just know about such a possibility and prefer modern technology when I have a chance to use it. Why is Vim so important, regardless of its, let's say, not obvious interface? Because Linux runs billions of devices all over the world, starting from smart vacuum cleaners and up to Android phones. So there are many cases when you have to edit some config files without the possibility to install your beloved editor, while there always will be Vim by default. As some bonus trick, I want to introduce you to the Vim Tutor. It's a simple tool to learn the most frequently used features of Vim. So, to use it, you simply type Vim Tutor in the console and press enter. It might turn out to be that this tool is not installed on your Linux system, like here we have now. But it's not a huge problem. To fix it, we will run just two commands. The first is sudo apt install Vim. It'll install the extended package of Vim editor. Likely it'll ask us for the password, then we have to enter it. If it asks for our confirmation during the installation process, then we have to press Y to agree, like yes. And the other command we will run is sudo apt install vim-runtime. And we'd better add here -y key at the end of the line, so that the installer doesn't ask us anything. With the -y option, we kind of agree with any question in advance. So when the second command finishes its run and we have our command line free, then we can run Vim Tutor again. What we see here is just a text file opened in Vim Editor. And this text contains about 7 small lessons on Vim features. When I say small, I mean that its text won't be more than half of the screen or so. I highly recommend you to get through this educational text, at least briefly. It will help you a lot with Vim understanding in future. For example, it explains work with Vim starting from navigation, which is possible to do with H, J, K, L symbols. It teaches exiting from the editor as well, the :Q, command, which we discussed too, the basics of text editing, etc. I highly recommend you Vim Tutor. To exit from it, we type :Q, obviously. By the way, after installing the extended package of Vim, it'll become a bit more user-friendly, which is quite reasonable for this editor. The last few words about Vim Tutor. It can happen that Vim Tutor will open its educational text in some other language. The reason is usually that it corresponds to Linux default language on your machine. So, if you want to change the language here, it is simple. After typing Vim Tutor in the console, you just have to add the desired locale, like DE for German or ES for Spanish, EN for English, etc. This section was devoted to text editors, and specifically to Nana and Vim, and as a bonus, Vim Tutor tool. The command in Linux that is used for searching files by default is find. Let's remember what files we have in our current directory. Okay, 3 files. So the find command without any parameters shows us all the files in the current directory. Of course, we can type in the name of the file we are searching for. But look, if we type, for example, new_file, this cannot find anything for us, although we know that the file with such a name exists in this folder. So our error was that we haven't specified the file extension. And now we've made sure that it's a part of the file name. If we don't remember the file extension or don't want to specify it for some reason, then we may enter asterisk, which stands for any string, including an empty one. So from the last 2 examples, we see it. The find asterisk command will output for us all the files in the current directory, as well as find without any option. Guess what we will have in the output if we type find new asterisk? The important moment here is that the new word is typed in capital letters. And you have already known that Linux is strict to the letter case. So this command will show us 0 files in the result. But for such occasions when we don't know in what case the file name was written, we have this -iname option. It will make the search independent of the letter case in the file names. Look at the result. The new file.txt was found this time. The asterisk symbol can also be used to substitute any file name when we know only the file extension, like this, find *.txt. This means that we want all the files with txt extension, and we don't care about their names, as we see in the result. To demonstrate further capabilities of the find command, let's create some new files. Before I started typing the command to create a file, you can check yourself whether you remember it from the previous lectures or not. The touch command can help us with fast creation of several files at a time. Let their names be report01, report02, report03. Check them with ls command, it's okay. So let's continue with our search experiments. Find report will show us nothing, as there is no file with this precise name. But there is a file named report01, and we can find it by directly typing its name to the end. To find all our reports regardless of the number, we can use the asterisk, like this, find report asterisk. So now we know about the asterisk symbol, that it is the alias for any string. But there is one more alias we can use here to substitute just one symbol, and it is a question mark. For example, if we type find report question mark, this will output for us all the files whose names start with the word report and have exactly 2 more symbols at the end of the name. If we change our command to find report and just one question mark, this will find us nothing, of course. For it to be more obvious, let's create some more conventional reports with 3 digits at the end of the file name. Okay, they're here. So now we will repeat our previous command with 2 question marks after the report word. And now in the results we see only files with 2 digits at the end. If we add one more question mark, then the results will only be files with 3 digits at the end. So to recap this aliases topic, the asterisk symbol can be used to substitute any string, including the empty one as well. While the question mark symbol means any but only one symbol within the file name. Let's get back to find command itself. Until now we used it to search for files in the current directory only. But we can specify the path where we want our files to be searched. For example, find tilde will output everything behind the tilde folder. What is the tilde concerning Linux path? We discussed it in the former topics. So tilde is the home directory of the current user. We have here outputted a huge bunch of files. But if we decide that we don't want to go too deep within subfolders during our search, we may use the -max depth option. We just add it at the end of the command string, like this. And now we've done the search exactly in our folder, without going into its subfolders, because the depth of the search is just 1, as we specified it in this example. So with this option we can decide how deep we want to look in our search. One more option of the find command we will talk over is -size. This one allows us to define the exact size of the files we are looking for. Or it can be used as a definer of lower or upper margin of the file size. Let's say we want only files with a size of more than 10K. Then we use the -size option with the refinement plus 10K. This will show us only our Romeo and Juliet poem and its backup that we made. The K letter here stands for kilobytes, obviously. If we want to indicate megabytes, then we will use the upper M letter. If we are interested in all possible specifications for the file sizes, then we can find it within the user manual for the find command. We open its complete manual by typing man find. And here we're going to scroll down to all the possible size suffixes. Lower K is for kilobytes, upper M is for megabytes, upper G is for gigabytes, etc. So it was the find command that we were observing in this section of our course, including its syntax, popular options, and some use cases.